Now that we have discussed how to convert the pseudocode into analytics, let's look at how we can validate that those analytics are working properly. In this lesson, you'll learn how to validate analytics to ensure their correctness. The purpose of performing validation is to ensure that our analytic is working as we intended. Even when our hypothesis is right, there are things that can go wrong when making the transition to an analytic. Here are some common issues that you may encounter. Incorrectly implementing the logic of the hypothesis is one common mistake, especially if you are new to the analytic platform. Typos can seem like small mistakes, but could greatly alter the logic of the analytic. For example, a misplaced parentheses, a missing or extra escape character, or a misspelling. In the case of our example query in the last lesson, we had several AND clauses and nested AND conditions within an OR clause. It can be very difficult to track those conditional clauses and to validate that what's written will perform as expected. A careful visual inspection of the analytic is important. It's also useful to adopt a test-driven development approach to the analytic, using known activity in your logs to confirm that the analytic responds as expected under a wide range of conditions. As you make changes to the analytic, rerun these tests to ensure that the changes haven't created a new logical error. Sometimes it's not always obvious what fields we need to use for the analytic, and we end up using one that doesn't match what we intended. In our example analytic, the pseudocode referred to the name of the executable. We had to understand that the image field and the original file name field were both available for sysmon event code 1. We had to then understand the differences between them and decide which one was most appropriate for our needs. It's always possible that we made a mistake in which data source we thought we should use. Sometimes we don't realize that the data source we are trying to use doesn't provide the data we need until we try to implement our analytic. In this situation, we may need to go back to a previous step of this method to reevaluate which data we want to start pulling in. In our example analytic, if we didn't have sysmon event code 1 available, we could have tried to get it collected or fallen back to an alternative data source such as Windows Event 4688. If we used 4688, the original file name field would no longer be available, so we'd have to update that aspect of the analytic as well. We can also run into circumstances where the logs themselves, although present, may have been incorrectly or incompletely parsed. When we encounter these instances, we should try to fix the problem whenever possible when the logs are being ingested or indexed rather than at search time, since accounting for it adds complexity to our analytic. If our analytic relies on correlating logs from several data sources or establishing a sequence of events, we should make sure to pay attention to the times that get assigned to the logs. Timing can be inconsistent for a variety of reasons, including ingestion delay, time zone differences, and variations if network systems are not synced to a time server. In a large network that crosses time zones, this can be a tricky component, as you may have to consider whether all logs are normalized to a common time zone like UTC, or if they're keeping their local time. What time zone are you in, and how might you have to compensate for the time differences when writing the analytic? For example, let's say our hypothesis is that most users log on to machines during normal work hours, and a login late at night should be considered unusual. If you only need to worry about a single time zone, this is a relatively easy analytic to write, as the time range is well defined. However, if your network spans many time zones like Japan, the US, Central Europe, and India, there is not a single time range to identify non-standard work hours. In addition to making sure the analytic does what we intend, we also need to try to optimize its performance, precision, and recall. Since these analytics will need to be run in a production environment, we need to take care of how efficiently the analytic runs. From a noise perspective, we need to drive down the noise, as a noisy analytic may be worse than no analytic at all, from an analyst's perspective. If we spend all of our time analyzing one analytics output, we are not looking at the output of other and perhaps more effective analytics. If we have multiple inefficient analytics, we will spend all our time spinning our wheels on meaningless events rather than focusing on events that are actionable. The larger environment that we are operating, the more efficient our analytic will need to be in order for us to use it effectively. We start developing the analytic on a test set of the environment before slowly scaling it up to meet the operating requirements we need for the full production environment. Normally, this will mean, in general, that the analytic must run and return a reasonable number of results in a reasonable amount of time and be run on data collected from across the environment. We can measure how well an analytic is optimized by assessing its performance, precision, and recall. And we'll dive into each of these aspects in the following slides. The process for improving analytics is iterative and can be broken down into several broad steps. We may not make changes to the analytic in all of these aspects each time, but we want to have a deliberate process to assess how the analytic is doing for each of these characteristics. In general, we start by validating the analytic is returning the results we want and expect. We then assess and optimize the analytic's precision, recall, and performance. If we are happy with the analytic's precision, recall, and performance, then we can look to expand how much time we're looking at, how much of the network we look at, and how many different benign and malicious behaviors are included in the data set. So we expand the time, terrain, and behavior windows to get closer to the scale that's useful for use in our daily operations. It's possible that rather than expanding the time, terrain, or behavior, we instead shrink it if we are struggling to analyze the data set we're currently getting back from the analytic. So this can ebb and flow as we refine this analytic. There are many different things to look for when validating our analytics, but here's an example list. From the query side, we are looking at ensuring the structure and content of the query is accurate. We covered several of these examples in the previous lesson, but let's review. Make sure the syntax of the query conforms with the syntax of the target platform. Carefully check the logic of the query. This can be especially tricky with multiple nested logic clauses. This first example returns results if C is true regardless of the values of A or B, but in the second example, A must be true and C could be false if B is true. So although these are visually similar and they use the same sequence of and or, they could return very different results. Also validate that the query uses the correct data source, event IDs, and field names. If the query uses something like we did in our previous example where it was event category and event type, it might not be clear which event IDs will be included in the results. So that's something to look into and keep track of. As we discussed previously, there might be multiple fields available with similar values. So be careful to choose the one most appropriate for your use case. We may also incorrectly format values that we are looking for in the different fields. So for example, we might be looking for shatasks when we need to look for shatasks.exe because the value in that field might include the file extension, and without it, we're not going to find that match. We also want to ensure that the results we get back are what we want. For example, we can make sure the events are getting parsed correctly. One instance of this could be that the fields contain many special characters, and it might cause events to be truncated early. We want to make sure that we are getting the events back that we expect and that the output is useful for analysts. In this lesson, we talked about an iterative process of improving an analytic and how to start with ensuring the analytic correctly implements the original pseudocode.